I'm Allie Harvey, and I'm going over Maddie Heddich's topics over 1 through 4. So our first question goes over topics 1 and 3, and it's about a Brita water filter attached to a kitchen faucet in a sink. And she's given up some knowns of the diameter of the faucet, the distance, the volumetric flow rate, and the volume of the sink. So we're trying to find the time to fill the sink. We want to find the pressure at the bottom of the sink, and we also want to find the time to empty the sink. So first, for part A, we're given our volume, and we also know the volumetric flow rate, so that's just a simple division to get our time to fill the tank. For part B, it's a hydrostatic equation, so we know that P1 plus rho GH equals P2. So if we're looking for P2, we have all the information given to just solve for P2. H, and this is when the sink is full, so we're using the height of when it is full. And then for part C, we're using Bernoulli. We can simplify. Our P1 and P2 will cancel out because they're both at ATM. Our V1 is negligible. Our Z2 is negligible because it's 0, because that's where our reference point is. And so now we can solve for our velocity exiting because we have all the information to simplify. And from here, we can get our flow rate because we know the cross-sectional area of the area it's leaving from. From here, we need to find the time to empty. So we're going to need to use an integral and integrate from 0 to t. And we also need to figure out if it's half full. This is how we can simplify from h to h final. How long it should take, you set those equal to each other, and you can solve for t, which you get about 30.7 seconds to empty. Okay, for Maddie's second question, she went over topics 2 and 4, which were buoyancy and macroscopic momentum balances. So for part A, it's about a jet ski with a rider, and we know the velocity, and we're trying to find the percentage of the jet ski that is submerged and the friction force. So we're assuming steady flow in compressible waters at 1 atm, 20 degrees C, and that friction is negligible. So first, for part A, the percentage of the jet ski that is submerged, we're going to be using Archimedes' law. And for buoyancy, we know that the density of the water times gravity times the volume of the water displaced is going to equal the density of the jet ski plus gravity times the volume displaced. And from here, we can simplify that our gravities will cancel out because they're the same. And we get volume displaced over the volume of the jet ski is going to equal the density of the jet ski over the density of the water. From here, we can solve to get that 15% of the volume of the jet ski will be submerged. And then for part B, we're trying to find the friction force. So here we have possible forces of pressure, shear, gravity force, and others. And using our microscopic momentum balance, we have in minus out plus generation equals accumulation. And this simplifies to negative out plus generation equals 0. So in the x direction. So from here, our sum of our mass of our velocity of the jet ski minus the velocity of the person equals our friction factor. We can simplify. We know that the velocity of the jet ski is 15 meters per second. That's given in the problem. From here, we can simplify and find our velocity of the person. And from there, find our m dot of our density of the water times our v dot, which is our velocity, which we get for about 5 kilograms per second. From here, we know that our friction force will simplify to be m dot and the difference between the velocity. And this ends up being about 5 newtons in the x direction.